All right, guys, we're going to discuss worksheet 9 now, which is kinetic model of matter. Just remember that all the calculation-based questions are out of syllabus, so there's no need for you to do. So just very quickly, Brownian motion is the random motion of smoke particles or any pollen particles that are light enough to be immersed in a fluid. Which of the is true? It is true that it is being bombarded by the invisible air molecules. The smoke particles don't actually vibrate by themselves between gas molecules. Wrong. Brownian motion is basically when you have anything that is light enough to be immersed in a liquid and moves because of the bombardment of the invisible fluid molecules, be it air or whatever fluid or liquid that is immersed in. All right, question 2. Pressure increases. Why does the pressure decrease? Sorry. Pressure decrease because a few things can happen. The speed of the molecule decreases. Yes, that's correct. Gas molecules, because this and this must happen at the same time. And this happens when the temperature is lower. So D, 1, 2, 3 is correct. Gas pressure increases with temperature. Why is it so? It is because it hits the wall more frequently. Remember, gas pressure is due to actually the molecules hitting the surface, right? Which means B is wrong because the molecules hitting one another actually does nothing for gas pressure. Gas pressure is defined by how much pressure exerted by the container due to the gas, not gas on gas, but gas on container. All right. Number 3 is just nonsensical. Combine into bigger molecules? No. All right. Question number 4 is slightly complicated. First, let's examine, because they say that the attached vacuum pump is turned on, so which means air is being evacuated out, which means there's air molecules here, which means you know that the pressure in the bell jar should decrease. Why? Because there's less molecules hitting the surface, because all the air molecules are being drawn out, so the hits will happen less frequently. So when it happens less frequently, then the force exerted will decrease. Pressure is force over area for gas pressure, and therefore the pressure in the bell jar decreases. All right. Because of that, the pressure in the balloon will also actually decrease to be the same as the pressure outside. All right. Currently in the balloon, the pressure here is the same as the pressure outside. When the pressure inside decreases, that's why the balloon expands, because initially the internal pressure will be greater than the external pressure in the bell jar. So when you start extracting the air molecules out from the bell jar, so the force exerted here will be greater than the force exerted on the balloon. That's why it expands. But then at the same time, because it expands, the number of molecules per unit volume will decrease. All right. Therefore, it will hit less frequently, and therefore the pressure will also decrease, because pressure is force over area. So decrease is correct. A. All right. The answers for Marshall Cavendish, I just want to change a little bit here and there. So I just want you all to take note. In solid, the molecules vibrate about fixed position. All this is unnecessary. In liquid, not necessary. The molecules are free to move about, but I believe the phrase that you are taught to use is slide past one another. So please just change that. For liquids, they slide past one another. In gas, move randomly at high speed is correct. This one, no need. All right. The next question, arrangement and spacing between molecules. Yes, molecules in solid are packed close together in a regular pattern. These both must be present for you to get a mark. No need. Minimal space, all this no need. In liquid, the molecules are arranged randomly is correct. Either just say randomly or no regular pattern. No need to say both at the same time. In terms of spacing, the molecules in liquid are slightly further apart, so you need these 2 points. In gas, the molecules are very far apart. Talk about the distance. And they are random. Yes, they are random. So you need to say all of this. All right. Brownian motion. This is the answer. Please, you are not allowed to draw curved lines. So if you draw your Brownian motion and you have curved lines like that, and then you say it's correct, no. It should not move in a curved line. Your pollen particle should move in straight lines because of collisions from all the invisible air molecules. All right. What is the effect on the motion of air molecules when I increase the temperature? It just moves faster. I don't know what this word vigorously is there for. What is the evidence? Evidence is what you can see because the smoke particles will move and change direction faster. All right. Why is that so? Because the higher the temperature, you remember, the higher the kinetic energy of the molecules, and therefore the higher the speed at which the molecules travel. So because the air molecules, the invisible air molecules are now moving faster, it will hit this, what is this, smoke? Yeah, the smoke particle will be hit by the air molecules more frequently, and each hit will be more forceful. So it will move further, then it will change direction. Okay, no curve. It will change direction very quickly, and it will change more often. All right. Again, calculation question no longer in syllabus. This one is quite standard. Why pressure increases when volume is reduced? All right. The reasoning is a bit all over the place for this question, so just follow my train of thought. When I decrease volume, number of molecule per unit volume, because the volume decreases, I should have more molecules in the same amount. Because of that, I will hit more frequently. Because I hit more frequently, there's a higher force felt on the container. Higher force because pressure equals to force per unit area. Therefore, a higher force means higher pressure. So this is how you should answer. It's a bit all over the place here, but yeah, you can just answer in as briefly as this as you can, and you should get the full marks. All right. This one is actually a data analysis question. So what is the diffusion speed of bromine at 313 degrees Celsius, which is this one? It gives you the time taken for it to travel through 10 cm of air. It takes 290 seconds. So that means velocity equals to distance over time. The distance it travels is 10 cm. Time it takes is 290. Then you can calculate at 3.45 as the answer here. 3.45 times 10 power negative 2 cm per second. So from the data, what conclusion can you draw about the relationship? You notice that as I increase the temperature, the time it takes for it to travel 10 cm is less. So therefore, you expect that the speed of diffusion actually increases, right? Because it takes less time to cover the same distance. So explain your answer. Very simple. Higher temperature means higher Ke of bromine molecules, which means they're moving at faster speed, which means higher diffusion speed. Yeah. So whatever is written here is just like that, but no need to be so draggy. Just write it as little words as you can. All right. Section C. Yeah. So this is just quite a standard question. Explain why the piston move outwards, but I think there are some things that I will find some problem with this Marshall Cavendish. So the reasoning should still be the same. When I increase temperature, the molecules have higher Ke, they move faster, higher speed. So this portion is okay. All right, because they move faster, I do not like the word that they use violently. What does it even mean, violently? All right, because they are moving faster, they hit more frequently, and you can say they hit with more force. Each hit is more forceful. So don't use the word forcefully and vigorously. Use it in terms of quantities that you have already learned in physics, which is force. All right, because of that, the force felt on the inner portion of the cylinder increase. Since pressure is force per unit area, pressure increases. So now you say since internal pressure is greater than the external pressure, so this one being the internal pressure and this one being the external pressure, there's a resultant force outward present. Because you need to, when they ask you to account for the increase in volume, you need to tell me basically why this piston moves. And remember in chapter 3, when we cover dynamics, when we want to say why something moves, we must talk about resultant force. So there's a resultant outward force, therefore the piston moves out. Right? So please just write like this. Don't need to I think they are short of points here for the Marshall Cavendish one. All right, this one is slightly a little bit more difficult. So they have a 90-degree and 25-degree piston. So this is 25 degrees Celsius. This is 90 degrees Celsius after heating. Of course, you expect that the volume will increase because you already explained it here, increase in volume. So now we need to talk about all of this. First and foremost, we solve the very easy ones because the number of molecules have not changed in before heating and after heating, but the volume has increased for this portion after heating. All right, therefore you expect that the intermolecular distance will be more because same number of molecules but the volume much larger, so this one increase. So this one is fine. All right, average size of molecule, no heating does nothing for the size of the air molecules. All right, so unchanged. After heating, you must remember what we always said, higher temperature means higher kinetic energy. So you can also say this very simply. Now, the difficulty is now talking about the air pressure. Why is it that the pressure here and the pressure at this point is the same? The reason being the external pressure here has not changed. They never mention anything about any changes to the external conditions, so the external pressure should remain the same. So you know from your study that if the internal pressure is greater than the external pressure, then your piston will start moving out to increase the volume. And the volume here will stop increasing, or the piston will stop moving such that the volume will start increasing when the internal pressure becomes the same again as the external pressure. So that's why it is unchanged. Now, the difficulty is the rate of collision. Now, we go back to what we learned. Higher temperature means higher KE means higher velocity, which means they hit more forcefully. So every hit of a molecule on any surface will impact or will give more force on that surface. Each impact will be of greater force. Now, you must go back and realize that we said the internal pressure in both situations are the same. Because the internal pressure for both situations are the same, but you know that each hit must be more forceful. So if I'm only looking at the area of the piston here, since internal pressure is the same, it means that the force acting on the piston must be the same in situation A and B, which means because pressure is force over area, right? So the force exerted on the piston here should be the same in both situations. But you know that each hit is already more forceful. So how do I account for the force being the same than the resultant force on the piston being the same? Right. So you account for this by saying that because each hit is more forceful, the molecules must be then hitting the surface less frequently. Right? Remember that the force felt on the piston is just due to the sum of all the forces acting on the surface of the piston due to all the collision. I just sum up all the forces exerted by all the collisions happening per unit time. That gives me resultant force acting on the piston. So for the force to be the same, there are two factors: each hit, how forceful it is, and how often I'm hitting it. So for it to be more forceful, my molecules must be hitting it less frequently. That's all I know about this. All right. So therefore, you know that the rate of collision must be lower. All right. Database question. Actually, you read it, it's quite simple. Why is it that it's quite a new novel situation? Right? Why do I use a gas instead of liquid in here? Because if I exert a strong enough force and the piston squeezes it and it's a liquid, and this fella here is not able to react in time because liquids are incompressible, this pressure here will be so intense that it will burst the cylinder lah, basically. So that's why the main reason is actually because gas is compressible and liquids are not. All right, so if I use a liquid instead of a gas, then when I suddenly put a large amount of force, then the cylinder will be more likely to burst lah. All right, this one is quite simple, just reading from the graph. 20 megapascals, you just read the graph, it's about approximately 0.15 meter cube. All right, again, calculation question, don't bother, no longer in syllabus. What is the assumption you make? For this, you assume that actually it's the same number of mole. I mean, it's quite understandable, this one. Same number of mass of gas in the tube and in the cylinder, in the test and in the actual cylinder. And of course, the temperature of the gas must be the same in both situations, lah. So basically, that is about all for this chapter.